Okay, everyone. So today I want to explain the Bitcoin white paper. Uh, I want to explain how it works from a technical standpoint. If you're sort of interested more as to like, well, why is Bitcoin a big deal or why is it important? I think the dominant narrative today is that it's basically digital gold or replacement for central banks. And as the price continues to appreciate, the more attention it's going to get and the more valid it becomes. But I actually wanted in this episode to show you how it actually works, like at a high level. Just go through the paper, because what's absolutely shocking about it is that the paper is just 8 pages long. Like that's it. Like 9 pages with references. So it's actually a very straightforward paper to understand. And if you were to compare this to, I don't know, taking like, let's say, a basic economics class or something, like your book will probably be 1,000 pages, whereas this is just like 8 pages. So yeah, it's not simple, but it's actually simpler than the other stuff that we're generally taught. So the main idea here is that, this is the title, right? So it's a peer-to-peer electronic cash system, and today, maybe it would be a peer-to-peer settlement network. And basically, like two parties can pay each other without going through financial institutions. And there's a few elements that work here. So one, it uses digital signatures, and I'll explain how that lets you have ownership of tokens. Uh, and then, but the historical issue with digital signatures, as presented by people like Wei Dai, is that you still needed a third party to prevent double spending, as in spending a coin twice that you don't have. So here instead, they propose a solution to this problem using a peer-to-peer network. Um, and it's actually very difficult to change this because hash-based proof of work system. The longest chain is a proof of the sequence of events witnessed and proof that it came from the largest CPU power. And as long as the majority of the CPU power is controlled by nodes that are not cooperating to attack the network, they'll generate the longest chain and outpace attackers. So messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will, accepting the longest proof of chain as proof of what happened while they were gone. Okay, let's talk about this a bit more. So this was sort of like the high level, and so like so. Let's just start with the basics, right? Like, well, what's a coin, right? So you can see here, like a coin is basically a sequence of ownership. So right, so it's basically like a coin used to, like, let's say you have a coin and it belongs to person one, then it belongs to person two, etc. And a coin sort of like moves, like changes hands. So how does this change of hands kept track of? Well, the signature here is signed via owner one's private key, and owner one can verify it using their public key. So you can see this sort of like creates like a chain like structure here. And if you have like basically the chain, that verifies that, you indeed own this coin. But this doesn't prevent you from spending it twice. And so the solution to that comes in the idea of like this here, like the next section with timestamp servers. So we want to be able to say that we want everyone to agree that when a coin changed ownership, we want to have a timestamp that everyone can agree to. And the way this timestamp would work is that at every block, you put in like a bunch of items. And in the next section, you'll see how this is going to be transactions. And you start hashing this sequentially. And every time you have like a new hash, like let's say hash three, the more you're able to trust what comes before it. So more specifically here, like the system they use is called proof of work. And the way proof of work works is that and every point of the network, you have a bunch of transactions in a block. So this is sort of like saying like, well, these transactions are true, and then the more transactions get added to subsequent blocks, that gives you even more confidence that they're true. But the only way you can add one of these blocks yourself is by expending CPU power. And so the idea is you need to like basically it needs to cost you a lot of effort to be able to add something less than the reward that you would get, but not easy enough that it just incentivizes you to just create an infinite number of blocks. Right? So another important thing they mention is that like Satoshi is very explicit that this is proof of work and not because like he essentially wants to make it one CPU, one vote, as in like the more CPU power you expend, the better. Uh, and had it been IP based, then you could just have a script that creates like an infinite number of IP addresses, and then anyone can allocate as many transactions to a block and then just generate coins for free. So another thing that's important to note is like, well, like you may have heard this a lot. Like, well, miners are solving like a complicated mathematical problem, and actually the problem is fairly simple. So basically, the way the problem is defined is you want to find some sort of value, like x, such that when you do SHA of x, you get a string that has a certain number of zeros. So for example, like the easiest version would be this, like it has 1 0 at the beginning. A bit harder is having two zeros at the beginning. This is hard because SHA, like hash functions are one way, so it's very difficult to reconstruct this from this. And because this problem is so hard, like we're using it as a foundation to generate the proof of work. So yes, this spends a lot of electricity. Yes, this is costly, but that's by design. We want to make it difficult to generate more coins for free. And if too many people are solving this problem at once, like the network automatically increases the numbers of zeros. So it basically always makes sure that there's a fixed number of blocks being created like every minute. And the way this is done is like once there's too many being created, the network automatically just adds a whole bunch of zeros and insists that more zeros be added. Um, so how does this work, right? So the core algorithm is really this. Like there's going to be a whole bunch of people making transactions on a network, and they get broadcast like to all the nodes in the network. So basically, everyone running the Bitcoin protocol, which you can run on a Raspberry Pi, with a 1 terabyte hard drive. So for like about $200, you can run your own Bitcoin node. Like that's it. You don't need to have a settlement bank or a central or a gold mine or whatever to do any of the above. So each node collects a bunch of transactions into a block, and then it does the proof of work. If the proof of work succeeds, it basically adds all of its transactions to this block. And if it was the first one to create this block, it gets a reward called the Coinbase, which is basically like it's essentially a free coin. So basically, the miners get rewarded for being the first to solve the proof of work problem. And so back to this idea now. So like as the proof of work keeps going, we're gonna have like a whole bunch of these blocks that are built like one on top of each other, and this is really what people call the blockchain. So whether the blockchain is useful for anything besides currencies, like I think that's still sort of an open question. But I would say like the most useful application for it right now is actually currencies, because it removes the incentives from central banks to be able to just issue currencies arbitrarily or forge their own currency. Um, so there's also some other ideas here. Well, like if you noticed here, having like a list of all the transactions of all time can be rather fiddly. And so what you can do is like there's like sort of like a bunch of compression techniques that you can have where, well, if you know that some transactions already happened and the chain got long enough, you don't need to keep track of them anymore. And so you can prune them with a data structure called a Merkle tree. So this is popular in databases as well. It's like so no surprise that you see it here. Uh, Another important idea is that one of the reasons why an often cited criticism of Bitcoin is that it can't process too many transactions, and that's true. And again, that's almost by design because it should be expensive to validate all transactions of all time. However, if you're willing to forego a bit of trust but want to make transactions go much quicker, what you can do is you can just take the latest block header and just use that to decide whether to approve a transaction or not. So you don't need the full node, but definitely people in the Bitcoin community always encourage that you run your own node because there's like sort of a saying like don't trust, verify. I think this is like very important to the way the Bitcoin community thinks and why people don't like doing this. Uh, but still, like eventually, if you want to do credit card payments, like, it's gonna be very difficult not to do this. Like if you're some sort of merchant or something. That said, even then, Satoshi recommends that you run your own. Well, and another thing is that, well, like the Bitcoin network can't process too many transactions, but each transaction can be potentially billions of dollars worth of value. So what you could do is you could batch in, like, let's say, all of your Starbucks payments like into one. Like, let's say you're using Cash App or Visa, then Visa would batch everyone's like transactions to Starbucks, and then they just like would send it one way to Starbucks. So you don't need to have like one transaction for each person trying to pay for a Starbucks coffee. So that's like another way to address some of these scaling problems, and with ideas like called like off-chain solutions, which networks like the Liquid network do, or payment providers like Cash App or PayPal. Um, and so like when people think about privacy, like I do want to say that like typically in the sort of regular banking system, right? Like you have some sort of identity. Like this will be like your checking number or your username, bank username. You make a bunch of transactions via a trusted third party like your bank, and then there's like basically the counterpart, like the person you're paying. Whereas in the Bitcoin model, like there is no concept of like basically what's public are transactions, but like no one really knows what your identity is, so it's sort of like privacy by design. That said, wallet addresses can be associated back to you. So I actually think that like if people talk about like oh like criminals use bitcoins, it's actually much more difficult to be a criminal using Bitcoin because all the transactions are public. It's much more difficult to launder money or do anything like that. So the last thing I want to talk about is this idea of like well like the way the Bitcoin network works is that like it works in a trustless way. Like you don't need to trust the other nodes in the network. And the reason that's the case is as long as like more than basically more than 50%. uh yes. So if more than 50% of people on the network are honest, then the chain is going to be accurate. And so here, what they do is like what Satoshi does is like so sort of like this simple probabilistic argument to say, well, let's assume an attacker which has less compute power than you is trying to hack the network. Like, why would it be really hard, right? So if you have so if the attacker has more compute power than you, then automatically they can compromise the chain. Uh, but if they have less than you, they have exponentially less chances of being able to fake the chain. And if you were to work this out, like this, like the probability that an attacker catches up can be modeled like with the Poisson distribution, times the probability that they could catch up from that point. And so then he shows like the code here for it. But really, the main idea is that like the more blocks are added, the smaller this number gets, which means the lower the likelihood of an attacker being able to compromise the network. Uh, so that's if the attacker has more less than 50% of the total compute power on the network. If an attacker has more than 50% of the compute power on the network, they can essentially tank the whole network. But by doing so, they would essentially make their own coins worthless. So there's sort of this game theoretic incentive that makes it so there's no real reason for you to completely compromise the network. Like you may want to, let's say, forge coins, but that's just like simply very difficult to do and would cost you a lot of money to keep up the lie. And so really like the main ideas are this, right? So this is sort of going back over the whole thing. We have tokens, and tokens are basically a sequence of transactions that are each verified and signed by owners public and private keys respectively. You have a timestamp server which lets you know exactly when transactions were added to a block. That way everyone in the network can agree to them. The proof of work algorithm uh, is designed to make it is designed to reward miners for validating transactions, and also makes it very difficult to fake transactions unless you're willing to spend CPU power, so you spend more electricity costs than you would money that you would make back. The main way the algorithm works is it's all public. Like all transactions are broadcast to a node. Each node collects a bunch of transactions into a block, and then they try to solve the proof of work problem, which is essentially inverting a SHA function with a fixed number of zeros at the beginning. When a node finds the proof of work, it broadcasts the nodes to all. It broadcasts the block to all the nodes, and once a bunch of nodes accept this, it gets added to the chain, and they just keep working on it. And the longest chain is considered to be the most accurate one. The way the incentives work is that tanking the network would cost you too much electricity or make the values of your coin really small, and you validating the network, uh, you're basically rewarded by getting more coins. Uh, Validating an entire blockchain is very time consuming because you're validating basically all transactions of all time. So this can be resolved by reclaiming some disk space with Merkle trees. Or you could essentially just trust the latest block header as opposed to revalidating the entire network. However, people in the Bitcoin community are very important, are very famous for saying don't trust verify because it's very cheap to actually run your own node. You just need a Raspberry Pi with a 1 terabyte disk. Another way to solve some scaling issues off chain is to batch transactions. You so basically this would be not on the blockchain itself, but some provider like let's say the Liquid network or Cash App or PayPal would do this. So this is one way to make a Bitcoin scale to credit card like transactions. Bitcoin is not private, like all the transactions are public. What's private is your identity, but if your identity becomes tied to your wallet ID, it's almost like everything's known about you. Uh, Once an attacker, uh, if an attacker has less compute power than the honest nodes, it becomes almost impossible for them to catch up the more blocks get added to a chain. So basically, it's sort of like a network that materializes security. Like that's why people call it like a money network. And yeah, so that's the main idea. And what I also really liked about this paper, or what I want to end on, is the list of references is very short, right? So B money was the idea of using token, like of having tokens be transactions. This is the paper on designing like the timestamp service. Uh, Same here. This is like about improving the reliability of digital stamping. So yeah, so all three of these papers with Haber, Stuart Haber. So Adam Cash, Hashcash, so also a very prolific tweeter, Merkle for the Merkle trees, and then this is sort of like prob- the probabilistic argument, not necessarily an argument about crypto. So I hope that was helpful. Like that's about it. You know, one really nice thing about Bitcoin is that you can actually go to GitHub and validate the code for yourself. Like Bitcoin Core is just all here. Like you can check all the code. You can check the issuance schedule, the 21 million constraint. Like it's all here. Also, I personally found it really interesting to follow some of these guys on, say some of these people on Twitter. They're like they all have like fairly strong opinions about like what Bitcoin should do and shouldn't do, and will give you a lot of useful information as to how it works. That said, a lot of it tries to fulfill, I guess, the original vision, except maybe having lots of transactions. I think that's mostly resolved now with off-chain solutions. So yeah, so I hope this was helpful.